On the morning of March 22nd, 1990, a man was found dead outside of his apartment in Brussels, Belgium. He had been shot 5 times in the back and the back of the head. His apartment key remained stuck in his front door, and beside him was an unopened briefcase containing $20,000 in cash. His name was Gerald Bull, a Canadian artillery engineer. At the time, Bull had been in the middle of work on Project Babylon, a gigantic and powerful space gun he was building for the Iraqi government. No person was ever charged with Bull's murder, though the list of suspects is high profile and a little scary. So, how did Gerald Bull end up here? Well, that's a bit of a long story. Today we're going to recount the tale of Canada's own crazy rocket scientist, a man who went from hopes of a unique method for spaceflight launches to weapons of war for a Middle Eastern dictator. We will be going from space guns to illegal arms dealing to more space guns and finally a grim demise. Prepare yourself, because this is going to get a little dark. Gerald Vincent Bull was born in North Bay, Ontario in 1928. His father, a solicitor, was well off until the Great Depression hit the next year, and the family moved to Toronto in search of work. It only got worse from there. Gerald's mother passed away in childbirth, which sent his father into a deep alcohol-fueled depression. Gerald was put in the care of his older sister Laura, who passed away from cancer in 1934, and Gerald was again moved into the care of his sister Bernice. 4 years later, he went to see his aunt and uncle, spending the summer holiday with them. These two were quite well off during the Depression, having won a large sum of money in the Irish sweepstakes, and they used it to send Gerald to an all-boys Jesuit school in Kingston, Ontario, my hometown. There he discovered a love of balsa wood model planes, beginning his interest in the world of aerospace, which would only continue when he entered Queen's University, hoping to end up in military officers' training school. A year into his studies at Queen's, Bull transferred to the University of Toronto, having declined an offer to go to medical school there, and instead enrolling in the school's brand new aeronautical engineering department. With it being as new as it was, there was limited criteria, and Bull was accepted into the graduate program at the age of 16. At the time, he was considered an average student. One professor noted that, quote, he didn't stand out, and his grades were straight down the middle of the line. Bull graduated from the University of Toronto in 1948, and later that year, the school opened a new Institute of Aerodynamics, now called the Institute for Aerospace Studies. It started very small, affording to have only 12 students at the time, and was funded by the Defence Research Board of Canada. After applying and being accepted, Bull was given the task of designing something that, in that era, was a relatively new and rare tool, a supersonic wind tunnel. Bull would use the wind tunnel and its construction as the basis for his master's thesis, and people were impressed. So impressed, in fact, that the tunnel was going to be prominently featured during the opening of the Institute's new grounds, leading to an overnight rush to get the tunnel operational in time. The work was completed by Bull and his team at 3:30 in the morning, and when the tunnel was switched on later that day, nothing happened. However, allegedly, Dr. Gordon Patterson, head of the Institute, simply pushed the button harder, and the wind tunnel promptly came online. By 1950, Bull had mostly finished his thesis work and received a request from the Defense Research Board. They wanted an unpaid intern to help out with the military's Velvet Glove missile project. Bull accepted the position and went off to work at CARDI, the Canadian Armament and Research Development Establishment. CARDI was formed at the end of World War II to keep Canadian wartime research teams within the country, as well as keep cooperating British teams away from Germany. The Velvet Glove project was a missile intended to be launched from a jet at supersonic speeds, requiring testing to be done by firing the missiles at high speeds from large artillery guns. This would be the beginning of Bull's lifelong passion for large artillery, the project incorporating techniques of both repurposing old guns, as well as better spacing out the amount of acceleration that the missile would be subjected to during launch. It was during this work that Bull met Mimi Gilbert, who he would marry in 1954. Somehow, he managed to balance time enough to have 2 children with her while he worked for CARDI, growing fed up with the team's method of testing the Velvet Glove with its 1,000-yard range and jump cards, as they were called, to measure the flight's progress along the range. He began lobbying for a wind tunnel to be built instead, something largely seen as too expensive and unnecessary. He gained the attention of professors at a university in Quebec, who allowed him and his team to construct a wind tunnel largely out of scrap parts for only 6,000 Canadian dollars, around 70,000 Canadian dollars today. Over the next 2 years, Bull would develop most of the technology and techniques he would need for his later career, including a telemetry system to track projectiles, smoothbore high-velocity guns, and sabots for increasing performance. To explain that last one, a sabot is essentially a casing for a round that would be discarded before impact, designed to keep it aligned in the center of the barrel when fired. And yes, you can also pronounce the word sabot, but I'm not French, so I'm not going to do that. In 1956, the Velvet Glove project was cancelled, causing serious political uproar due to the $24 million that had been spent on its development, around $273 million today. The Defense Research Board moved on to anti-ballistic missiles, and Bull moved on to hypersonics research and detection technology. CARD's funding began to be dramatically cut back. Sound familiar? Something Bull was very vocal about, calling the liberal government of the time, quote, second-rate lawyers and jumped-up real estate salesmen. During this time, some United States teams began to visit Cardi, becoming impressed with Bull's work. He began studies of the then-in-development Avro Arrow, an interceptor aircraft intended to serve as the Royal Canadian Air Force's primary interceptor in the 1960s and beyond. Bull began experimenting with the idea of firing scale models of the Arrow out of his artillery guns to test its stability. He began with a successful test firing of a model Gloucester Javelin, taking shadowgraphs that showed supersonic shockwaves in more detail. He then moved on to testing model arrows with the same method, but the project was, again, cancelled shortly afterward, angering Bull greatly. He quickly gained a reputation for being temperamental and difficult to work with, due to his strong dislike of red tape and administrative barriers. He also did something in 1958 that would, in a way, foreshadow his later methods of sleight of hand and conning those above him. With the launch of Sputnik 1 in the previous year, the aerospace world turned its attention to space, and Bull decided to take advantage of this. He leaked a story to the media that Canada would match the Soviets' feat by placing a high-velocity gun in the nose of a US Army Redstone missile and use it to put a satellite into orbit. The story was, of course, a complete fabrication, but it led to a major stir in Canadian newspapers and renewed attention on Bull and his work. The CBC, the Canadian Broadcasting Company, made a piece covering the activity at Cardi, including lengthy sections on Bull's artillery weapons. The attention would keep Bull in mind for a number of high-ranking people, which would become important to him when he resigned from Cardi in 1961 after a lengthy argument with his superiors over paperwork. It was time for the next big thing. Gerald Bull began work as a professor for McGill University, which was in the process of building up a new engineering department that Bull became pivotal to. Using contacts he had maintained at Cardi, he set about equipping the school with instrumentation to lead the field of aerodynamics. He donated a plot of land he had purchased with his wife to be turned into a ballistics lab named Highwater Station. In late 1961, Bull visited several of his old U.S. military contacts at Cardi and proposed a new research project. As the U.S. military was still experimenting with the logistics of atmospheric reentry, and rockets to do so were very expensive, Bull proposed a new method: fire them out of a gun. Funding was arranged, and Project Harp began, standing for High Altitude Research Project, not to be confused with HARP with two A's, the High Frequency Active Auroral Research Program in Alaska. The U.S. Navy provided two surplus 16-inch battle guns, which were retooled into 16.4-inch smoothbores, and welded together to increase the gun's length. This was, again, done on the cheap, something Bull was very good at negotiating. Only $2,000 US for the entire project, around $20,000 today. However, the resulting HARP gun was far too large for use at Highwater Station, and the team began looking for a new home. McGill University suggested a meteorological station they ran on Barbados, arranging for a firing site on the southeast coast of the island. Because the guns couldn't be offloaded at the shore where they would be set up, the project began to grow by employing hundreds of locals to move them up the coast via a purpose-built railway. Bull used the employ of these locals to encourage them to pursue engineering degrees, using the work they did here as a stepping stone to higher education. The eventual goal of HARP was simple, though it was often clouded by funding and interest from the U.S. military. Gerald Bull wanted a unique and cost-effective way for Canada to enter the space race, and he saw these massive artillery weapons as the way to do it. Instead of the costly process of manufacturing and launching rockets to get a payload into space, the alternative, he saw, was to fire them out of a gun. He was inspired by a childhood reading of Jules Verne's From the Earth to the Moon, in which several people reached the moon from a capsule fired by the massive Columbiad space gun. While Verne's novel is obviously fictional, some of the fundamentals are sound. Human beings are a little too mushy to survive the G-forces of a gun-based launch above the Kármán line, but some machinery wouldn't be. The extreme length of the gun barrel would also help to spread the acceleration out over a longer distance, allowing for a rugged satellite to be launched from it. Of course, once in space, this satellite would need its own propulsion to place itself into a stable orbit, otherwise it would fall back to Earth. However, it may be surprising how little that extra propulsion needs to be. requiring only something like a small, simple, solid-fueled stage similar to Explorer 1, the first satellite launched by the United States, to raise its perigee above the atmosphere and keep it free-falling around the Earth. By 1962, the Harp gun was installed and construction of the surrounding infrastructure neared completion. The U.S. Army Research Office had increased financial support for the project to around $250,000 a year, around $2.5 million today. In January of the next year, the gun was test-fired for the first time, raised up to an angle of around 80 degrees, and launching a 315-kilogram slug to an altitude of 3 kilometers. Reportedly, Bull was the last person to head for cover in the Harp bunker prior to the gun firing, and after this first test, real operations began. The metal slug was replaced with a small finned missile called the Martlet, named after the martin bird on the crest of McGill University. The missile was protected by a wooden sabot designed to split apart after the projectile left the barrel, and were equipped with a variety of payloads such as metal chaff, meteorological balloons for atmospheric data gathering, and telemetry systems to track their flight. The first Martlet flew to an altitude of 26 kilometers and was the first Harp projectile to feature a radio transmitter to track it. The second test series using a Mark II Martlet quickly broke world records for gun-launched altitudes by reaching 92 kilometers, just on the edge of the arbitrary boundary of 100 kilometers, the entry point to space. Further Martlet II firings regularly reached altitudes of around 80 kilometers, and after around 20 of them had been fired, a third-generation missile was approved and designed. The Martlet II tests costed only $2,500 to $3,000 per round, between $24,000 and $29,000 today, and took only a half hour to load. These low costs and turnarounds convinced the U.S. Army to increase the project's funding to around $1.25 million, and in 1964, Canada's Department of Defense Production agreed to match this for a total of $3 million yearly, or $30 million today. However, opposition within Canada's government caused delays in actually providing this funding. For instance, the funding promised for July 1964 to June 1965 didn't arrive until May of 1965, forcing McGill University to cover the funds as best they could. Harp began to modify their gun to improve performance in 1964, welding a new section of barrel that increased the barrel's length to 8.9 meters, or just over 29 feet. By 1965, the entire gun assembly was extended to 120 feet, or 36.5 meters, officially making it the largest piece of operational artillery in the world. With these changes, muzzle velocity was greatly increased, as well as improved apogee of the test firings, and Martlet III launches regularly reached the ionosphere to gather atmospheric data. At this point, Bull began writing proposals for larger guns that were 3, 4, and 5 feet wide, the larger calibers reducing G-forces inside the barrel and making his end goal of a gun-launched satellite far more realistic. At the same time, Harp began work on the Martlet IV, which would use rocket engines mid-flight to push the projectile all the way into orbit. By 1966, Harp was expanded with 2 more 16-inch guns, one at high water range, which was only capable of firing horizontally, and another at Yuma Proving Ground in Arizona. The latter would result in a Martlet II launch that set a still-standing world record for the highest altitude of a gun-launched projectile, 179 kilometers, 79 kilometers over the Kármán line and into space. That's 111 miles for you Americans. Over the next 2 years, Gerald Bull underwent immense pressure to keep Harp funded and appreciated by those who funded it. Similar to Wernher von Braun, he tried to use the military interest in the project to sustain his eventual civilian satellite goal, but things began to quickly fall through.
Why have you received more support from the Americans than from our own people?
Well, that's rather a tough question. We felt that the Americans would be more interested in the technique because of their very diversified program and their known diversified approach to all problems.
For Americans, pressure from the Vietnam War and NASA's large-scale traditional rockets strained the project's funding, and for Canadians, a number of very vocal critics were pushing for Harp's funding to be allocated elsewhere. Bull did his best to rebuke this alongside Donald Mordell, professor of mechanical engineering at McGill.
Moi, je suis toujours, je crois que c'est absolument nécessaire pour un pays comme Canada de participer dans ces programmes. Premièrement, le programme Harp, c'est un programme mêlé dans le monde scientifique qui donne beaucoup de renseignements et donne le capability pour nous autres en Canada de travailler avec les scientifiques, les ingénieurs américains.
However, their efforts ended in vain. In November of 1966, the Canadian government announced they would no longer provide financial support for the HARP program, the last of it being given in June of the next year. Critics railed against even this last batch of funding, resulting in it eventually being transferred to a Canadian satellite program called Alouette, a rocket range in Manitoba, and the new Black Brant sounding rocket. Bull quickly tried to save face by making a long-shot offer. If the government would agree to continue this last batch of funding, he guaranteed that the program would become self-sufficient afterwards. This meant severe changes. Suborbital research was simply not enough, and they would have to put all their efforts into launching a satellite into orbit, no matter how small, simply to prove that it could be done. Despite their efforts, the Martlet 4 was woefully behind schedule, and a second, smaller and simpler Martlet 2G was attempted and tested, but never quite reached the stage of development that it needed to. Using the Canadian bailout to justify the difficult position they were in, the U.S. Army similarly pulled out of the HARP project. The decision was so abrupt that the Yuma gun was shut down in the middle of test operations, not even allowing them to collect data on the most recent firings. This phase of the dream was over. The 16-inch Barbados gun remained in place and is still there to this day, slowly rusting away as it returns to nature. Devastated by the loss of the HARP program, Gerald Bull returned to Highwater Range in Quebec with the intention of commercializing long-range artillery. He had placed a clause in his contract with McGill for Highwater that required them to return the range to him in its original, natural condition. Not wanting to foot the massive construction bill, McGill simply gave Bull the entirety of Highwater as it was, equipment and all, allowing him to salvage some of Harp's resources for a new venture, the Space Research Corporation. Bull became an international artillery consultant and over the next decade would do work for a number of governments including China, Chile, Taiwan, and especially South Africa. He adapted the Harp gun's smoothbore design into a new reverse-rifled design that allowed for a more versatile gun that could fire a variety of existing ammunitions, retooling old things to work like new. In 1975, the SRC designed a new gun, their primary product, the GC-45 howitzer. This gun remains in operation by 15 different countries today, capable of firing at ranges of up to 30 kilometers with extreme accuracy and 38 kilometers while sacrificing some of that accuracy. Again, that'd be 18 and 23 miles, respectively. The company experienced their first major commercial success in the sale of 50,000 shells to Israel, allowing them to counter battery against longer-range rockets fired from Lebanon. Once they had completed the new howitzer, Bull got a little ahead of himself. Having been visited by U.S. military officials who claimed to be impressed with the design and expressed interest in large-scale purchases, he put the gun into production. However, in 1976, the United States declined to buy any of them. Needing to offset the massive production costs, he searched across the world for a buyer and found one with devastating results. In 1977, Bull orchestrated the sale of 30,000 155mm artillery shells, as well as gun barrels and plans for the new howitzer, to Armscor, the state arms corporation of South Africa. The shipments were routed through Spain, the gun assemblies made somewhat secret, because Bull knew that what he was doing was technically illegal. The sale was in direct violation of UN Security Council Resolution 418, which had made arms export to South Africa expressly illegal.
Are you sure they're in Spain?
I know that some of our people said they've talked to them and seen them in Spain, and
According to what we've been told, they were re-exported out of Spain on a ship called the Breezan, and it gave its destination as Canada.
Where did it go?
South Africa.
South Africa. I haven't got it. We'll certainly check it.
He was allowed to do this for some time, and it's difficult to see through all the black sensor bars, but it's very likely that Armscor was encouraged to make the purchase by the CIA, who were considering South Africa's ongoing conflict with Soviet operations in Angola. For them, if anything went wrong, it would be a deniable operation. And it was, the moment the cargo vessel Tagalaland was caught shipping the weapons. U.S. Customs initially considered prosecuting up to 15 people involved, but at the end of the day, the only person who faced any charges was Gerald Bull. Having been told he would receive only a token punishment, likely a fine, Bull pleaded guilty to illegal arms dealing and was sentenced to 6 months in the Federal Correctional Complex of Pennsylvania. The Space Research Corporation was liquidated, and no evidence of suspected collusion by the US government was ever heard. From this point forward, Bull would do no further dealings with the US or Canada. He felt betrayed, manipulated, and thrown under the bus. While one department of the government shook his hand and told him to keep going, another department was holding a knife behind its back. When Bull was released from prison, he made statements to several newspapers that he would never set foot in the continent of North America again. He packed up everything and moved to Brussels, where he would spend the rest of his life.
I feel more than betrayed. And I feel that all of the memories and all the traditions and everything that I thought the country stood for has been betrayed. What I did and what I built, to see it cheapened, to see people trying to degrade me personally, as common criminal. For what?
Brussels was, at this time in the early 1980s, considered the center of the world of arms dealing.
In the same way as they say all roads lead to Rome, all guns point from Brussels.
It was a good time to be in this business. The Iran-Iraq War was in full swing, and Saddam Hussein was struggling with old, outdated Soviet weaponry. Having been told about Bull's remarkable ability to upgrade old guns, he tried to contact Bull, who was at the time busy flirting with the idea of selling his ideas to China. While also technically illegal, international politics revolving around China resulted in lax enforcement by the US government, allowing Bull to get away with it this time. In 1984, one of Bull's associates was caught at the Canadian border with governments and a contract with China that all held the same signature, GVB, Gerald Vincent Bull. One investigator tried to build a case against him, but was told by higher-ups to let it go, not wanting to strain US-Chinese relations, which were, at the time, quite close. While doing his dealings with China, as well as another deal with Austria who bought a license to develop Bull's improved howitzer, the Iran-Iraq War had bogged down into bloody trench warfare, an arena in which artillery is king. Saddam Hussein orchestrated sales of new weapons from South Africa. Weapons, it turned out, which were direct descendants of Bull's GC-45. With the United States now involved directly in the war, American soldiers were now facing over 500 artillery weapons developed by one of their own citizens. Gerald Bull still had dual citizenship with the United States and Canada at this time. It is said that Bull liked to drink, and the more whiskey he imbibed, the more he would talk about his ideas for superguns.
You see, the more whiskey he and my colleagues drank, the farther the gun shooted. But in the end, it was about 1,000 kilometers.
He went back to research he had done into the V3, a supergun that was in development by Nazi Germany but never finished, and unrelated, by the way, to von Braun's V2 rocket. All of his boasting about supergun capabilities eventually led him back to the United States for the last time, something he said he would never do, making presentations about his ideas to military officials. He talked about the Paris gun and the V3 and what they outlined for future possibilities, an intercontinental cannon. However, his hopes were dashed yet again when the Pentagon passed on the proposal, so naturally, Bull went searching for another customer, and he found one: Saddam Hussein. Evidence suggests that Bull was in Baghdad by 1988, negotiating a deal for a new and powerful weapon to be built for Saddam Hussein and the Iraq military. The go-ahead was given, and the project was given a name: Babylon. If this HBO movie dramatizing Bull's life is accurate, the name was given because Babylon once had the Hanging Gardens, one of the 7 wonders of the ancient world, and Bull said he was going to make an 8th. He outlined a cost for the project of $10 million, which would cover both the full-size Babylon supergun and a smaller one nicknamed Babylon that would be used for initial testing. Hussein saw Babylon as a way to achieve the same thing as his Scud missiles, but without being able to be shot down by Patriot missiles and requiring no guidance systems. Babylon was carried out as a clandestine cloak and dagger operation, with Bull contracting out construction of the gun's various segments to different companies, hiring qualified engineers who would agree to such levels of secrecy. The barrels were engineered in England, the supports in Greece, pipes, pumps, and valves for the recoil system from Switzerland, gunpowder in Belgium, and other steel parts in Italy. Overall, 8 different countries put work into developing the Iraqi superweapon. To maintain secrecy, the massive sections of gun barrel were shipped under false pretenses, claiming them to be piping for a sewage system. Despite all of this covert work, eyes were on Bull and his work once again. He confided in several friends that he had received threats from the Mossad, the Israeli intelligence agency, urging him to stop his work on Babylon. He was warned that if he carried on with the project, they would need to pursue, quote, harsh action. One rumor even states that a more subtle and rather amusing threat was carried out when Bull returned to his apartment to find it was broken into, and nothing was stolen, but every piece of furniture was rotated by exactly 90 degrees. Bull, however, didn't back down. He gave no indication that he was going to give up on Babylon, and his fate was sealed. On March 22, 1990, Bull rode the elevator up to his apartment, and at the same time, a team of assassins rushed up the stairs with suppressed weapons. Meeting at his front door, 5 shots were fired, and Bull went down for good. The assassins vanished without a trace. Gordon Thomas, investigative journalist, states that Bull's murder was sanctioned by then Israeli Prime Minister Yitzhak Shamir, and within hours of the killing, Israel was engaged in distributing false stories to European media attributing his death to Iraqi hands. Bull's work across the world had made him both an asset and a liability, making other suspects extend to the British MI6, the American CIA, or the governments of Chile, Syria, Iraq, or South Africa. However, the most frequently accepted notion is that Israel remains the prime suspect. Some parts of the Babylon Supergun were still in transit when Bull died, and were seized by customs of the United Kingdom in the same year. After investigation, one section was put on display at Fort Nelson, Portsmouth, and another at the Royal Artillery Museum in London. Most of Bull's team returned to Canada, and after the conclusion of the Gulf War, remaining Iraqi Babylon equipment was permanently destroyed. Gerald Bull's dream would never be revived. A few attempts have been made over the years, but never gained enough funding to go into proper development. Despite the work that Harp did to prove the feasibility of gun-launched satellites, to this day, there is only one method to reach low Earth orbit: conventional liquid or solid-fueled rockets. The controversial story of Gerald Bull remains as a cautionary tale. Brilliant people with brilliant ideas, when they face enough opposition, can become extremely dangerous. Desperate for anyone to listen to their work, they may end up shaking hands with the devil. Hell, if Gerald Bull hadn't ended up in Iraq, it's possible that today he'd be working for Spin Launch. It's a very similar concept. However, we will never know.